All right, lesson 3-6, different theorems about roots of polynomial equations is the title of it. So the first thing from the graph over at the right, 4 is a 0, but we have a degree 5. So how can you determine if 4 really is a 0 without just plugging it in? And I would say what they're getting at here is if 4 is, we could definitely do this, right? You could go back to your synthetic division. So one way is plugging 4 in for x, and it should end up equaling 0, but bring your 8 down, 32, add those straight down, 0, add straight down, 0, add that, bring that down, 4, add that down, 16, seems like I might have had a mistake there somewhere. Let's double check that quick. So we've got 8, negative 32, 0x cubed, so 1x squared is 0, x and the negative 4. Bring the 8 down, 4 times 8, 32, add straight down, 0, 4 times 0 is 0, add straight down, that's a 1. 4 times 1 is 4, add straight down is 4. So if I didn't make a mistake here somewhere, I would say that 4 should not be. Do a quick little double check here on that equation. 8x to the 5th minus 32x to the 4th plus an x squared minus a 4. Graph that. Maybe I'll type it into decimals quick so you can see what I'm seeing. 8x to the 5th minus 32x to the 4th plus an x squared minus 4. I'll share my screen with you so you can see this Desmos equation. Let's see if we get the same graph that they did. 8x to the 5th minus 32x to the 4th plus an x squared minus a 4. Let's see what we have there. I don't think my graph looks like their graph. So I would say that no, that doesn't work compared to this graph. So I think we've got something wrong with their graph or their equation. I'm assuming I actually have their correct equation typed in there, because it looks something like theirs, but not quite. It certainly doesn't go through 4 over here. Oh, maybe because I got that 8 out there and I'm not supposed to. So let's see if we zoom in here now. All right. Well, that's still not exactly 4. It's close to 4. So I would say that was exactly their point, is when we tried this 4 is not actually a 0, so you can't actually use that. All right, so then the next problem, see that storage shed they've given us a picture of. We've got a width of x, we've got a height of 2x minus 3 and a depth of x minus 2. And then they're telling us on this problem that the volume is exactly 154 and the solution to the equation. So if they already multiplied and we're supposed to then find the solution to 2x cubed minus 7x squared plus 6x, subtract the 154 over. And to solve this problem, they like to tell you that one way you can do this is if you take the 154 and you put it over the coefficient of this 2, that all of the factors that you have there are the only possibilities for your zeros. I would suggest, I'm going to always let you use a graphing utility like Desmos or graphing calculator. So I would say let's go over and type that equation in and see if we can find out what some of our zeros are. So again, let me share my Desmos screen with you. So this is the problem I was trying to do here. Trying to work on this shed. And we've got this equation. I moved this 154 to the left here, subtracted it over. And now I'm trying to find out what are my dimensions. So what is x? And I'll subtract 2 from that to find it, and multiply by 2 and subtract 3 to find the height. So if I'm going to solve that in that problem, I'm going to put it into Desmos quick. See if I can find what any of my factors are by looking into Desmos. Two x cubed minus 7x squared plus 6x minus 154. Okay, so I think that's the equation that I did have. So looking over here, so 5.5 is one of my zeros. We'll have to see what that is and what to do with that. And then is there another one here somewhere that I just can't see, or is that the only one? So it looks like that's the only one. Anything else must be like a imaginary root or 0. So if x is 5.5, we have x being a 5.5. Let's go back over to the problem. We could check that and just see if it does work out. So 5.5, let's go up here. 5.5, this one where I subtract 2 from that would be 3.5. And just 2 times 5.5 is 11, take away 3 is 8. So if I multiply all those out, do I get 154 would be the question. I'll just grab a calculator here and say 5.5, 5.5 feet there, times 3.5, times my 8, and I indeed get 154. So the 5.5, if you went 2 times 5.5 cubed minus 7 times 5.5 squared plus 6 times your 5.5 minus your 154 and evaluated, you would indeed get 0. So that's one way to come up with your solution there, and I think it's probably faster, a little less complicated. All right, what are all the complex roots of this polynomial? So again, taking this 2, putting over that 3, so a 2/3 is what it would suggest, or a negative 2/3, or it could be a 1/3, or it could be a 2, because 2 times 1/3 is 2/3. But again, I'm going to tell you that I think in today's world, it's going to be reasonable to suggest that you can have the technology to help you. So let's see if we type that equation in again to a Desmos. Let's see if we can just find one of our zeros for us. See if that 2/3 is indeed what we get. So we've got our 3x to the 4th plus 4x to the 3rd plus 2x squared minus x minus 2, I think, was the original problem, if I wrote it down correctly. 3x to the 4th plus 4x cubed plus 2x squared minus x minus 2. And if you get back in here where we can see what we actually have, I zoomed out so far. So we've got one answer there at -1, and this one at 2/3. And 2/3 is what we suggested. So -1 is one of them, and 2/3 is the other. So what we're going to have to do is we'll have to factor those two out and see what's left first. So I hope we're on the right screen now, sharing the problem back with you. -1 and a 2/3. I'm going to take the -1 out first. Synthetic division, coefficients off from everything. Bring down the 3, multiply -3, add straight down. -1 times 1 is -1, add straight down. Multiply, that's -1. No, that doesn't seem like that worked. I must have done something too fast, or I didn't type my equation in right or something. Bring down 3, 4, 2, -3, 4, 2, -1, -2. Bring down my 3, -3, add 1, multiply -1, 1, multiply, oh, -1 plus 1, right there. -1 plus 1 should have been -2. And then -1 times -2 is +2, add straight down remainder. Okay, so that works. So that'd be a 2, an x squared, but we still have to take out the 2/3 yet as well. So now we got a 2/3 that's a 0 also. So for that one, 3 times 2/3, 3's cancel, give me a 2. Add straight down, I got another 3, so then that's the same thing, another 2. That's the same thing again, another 3 times 2/3 is a 2, add straight down, and I've got a 0. So now what do I have? I've got this last thing would be, and it's like 3x squared plus 3x plus 3. Except for the fact that because it was a 2/3 out here, that sometimes you have to account for that in there as well. So after you get all of those factored down, what are all the complex roots that you have left after that? So the complex roots, because so far what we have multiplied is we have, for the -1 would be x plus 1, and for the 2/3, if you multiply both sides by 3, you'd have that, and so the factor would be subtract the 2 over 3x minus 2. So this is what we have so far. Notice I've already got my 3 on the x squared, right? So this 3 right here, I can't have any more of that. So this all has to be divided by 3. It comes from the fact that we're 1/3 there as well. So we need x squared plus x plus 1. And then to find the complex roots, we have to do quadratic formula on that. So x equals negative b, there should be right there 1 plus or minus the square root b squared minus 4ac, which is just be 4, all over 2a. So negative 1 plus or minus square root of negative 3 all over 2, or negative 1 plus or minus I times the square root of 3 over 2, or negative 1/2 plus and minus I squared root of 3 over 2, separate like that, for your two imaginary roots that they asked on that problem. All right, continuing on after that. Suppose a quadratic has p as one of the rational zeros and irrational at a plus square root of b. So a rational means like a regular number. So one of them is, it could be like x minus 2. The other one would be something like x minus a plus the square root of b. The question is, are the coefficients going to be rational? But there's no way to get rid of this one if you multiply it over onto here. So if you're going to multiply it times that x, you're going to still have a square root in there. So the answer would be no, because there's no way when you're multiplying it times the other side for the square root to go away. So you're going to be stuck with that. These are kind of more general questions. This one, what if your two roots, though, are conjugates of each other? So what if you have an a plus square root of b and an a minus square root of b? Remember, those are called conjugates. When one of them is a plus and one's a minus, they're conjugate pair. So look what happens when you look through here. You started out with square roots in here, but with the conjugate pair, remember we talked about that before, where the square roots actually cancel each other out. And when you get done down here in your final answer, do you see any of the square roots left in the problem? No. So when your roots, when they come as conjugate pairs, that turns the whole quadratic back into like rational or real type of numbers instead of those irrationals with the square roots. So anytime if you have a real and just one irrational, you're going to be left with the square root in there. That's what we were talking about before, unless they come as a conjugate pair. So imaginary, see how these imaginaries right here. So if your final answer or your quadratic looked like this, but you factored it down, you can actually factor it. It's just that your imaginary parts are going to be a conjugate pair. So if I know my quadratic and I know one of my roots is a complex number, there's a good chance, almost certainly, then that the other one has to be the conjugate pair for that. So you could try that, and you can actually see right here that that is indeed the case, because it's already been multiplied out for you in that example. Same thing. You've got a conjugate pair here, so when you do multiply that out, in the end, you should end up with real numbers and not conjugates. So multiply the four factors, you 3 minus 7i. So that's going to be these two that had these two conjugates. After you multiply those together, the other two from this one, x conjugate pair again, x minus 4i, and then this is really going to be x plus 4i. And then multiplying all four parts of those out to come up with your final answer down here that has all real numbers, because it all had those conjugate pairs in it. And that's it. A little bit tricky, a little bit complicated, but I think you can do it. Might take a little work. Watch the video, rewatch the examples.